Good afternoon everyone. I am Chanda Devnath, one of the PMRF fellows. So I am pursuing my PhD at ISR Berhampur. So I am the TA of this Mechanisms in Organic Chemistry course instructed by Professor Nandita Madhavan. So in the last few classes we were discussing about different type of organic reactions mechanism. Then we started discussing about the theoretical explanation behind all this type of mechanism. So in last two classes I have discussed about Hammet principle, rate law, naturophile diagram, and then we started discussing about Hammet principle. So today this is the overview of the last class. So today we will continue with the Hammet principle. So what is Hammet principle? I discussed earlier also. This principle, when introduced, it was mainly based on the deprotonation reaction of the benzoic acid. So to apply that concept to other unknown reaction, Hammet introduced this equation where the log Kx by K is equal to sigma P. Where Kx is the rate constant with different type of substituent and Kh is the rate constant of when there is no substituent present. So rho is called as reaction parameter constant. It tells us the sensitivity of a reaction in comparison with the deprotonation of the benzoic acid. So this is another form of this equation. This is also known as a linear free energy relation. So what is the significance of rho? When rho greater than 1, the reaction is more sensitive than that of benzoic acid. When this is less than 1 but greater than 0, then that is similar kind of sensitivity like benzoic acid. When it is less than 0, that is a negative value. That means any positively charged intermediate is getting involved, and when there is rho equal to 0, it means no sensitivity towards the substituent. So this is the overview. If for when rho value is positive, that is greater than 0 or less than 1 or greater than 1, the graph will look like kind of this one, and if it is less than 0, that means the slope is equal to 0, then it will be a graph kind of this one with a negative slope, where in this case the slope is positive. Okay. So then I gave one question to solve by you. So this is the answer, where I asked about determine the rho effect. So if in this reaction I have asked to determine the rho effect. Now you can see in this case this O minus is attacking to this center and is getting removed from this. It is a kind of a SN2 type of reaction. But in this reaction, if X equal to electron withdrawing group, what will happen? This charge will get delocalized into the ring. Whereas if it is electron donating, there will be a reverse case occur. Now from that thing you may think that if there is a negatively charged species is there and we are adding electron withdrawing group, then rho value should be positive, as we have discussed earlier. If there is a negatively charged intermediate like phenoxide or benzoate anion and there is an electron withdrawing group, usually the rho value is positive because the negatively charged species get stabilized. But here in this case, while the reaction, the negative charge is getting flowing away from the ring because we are attacking by the O minus to the electrophilic center. So the negatively charged electron is flowing away from the ring. So to the transition state, because of that, if we add an electron withdrawing group, what will happen? The negative charge density on this oxide anion will decrease. Therefore, the rate to transfer the electron charge to this electrophilic center will decrease. Therefore, in this case, rho value will be a negative value because by adding electron withdrawing group, the rate will decrease. Okay? Because in this case, this is not the reacting center. This is acting as a nucleophile. As much as we adding an electron withdrawing group, the nucleophilicity of this center gets reduced and it reacts slowly than that of the nucleophile having an electron donating group. Let's solve this one. So what they have asked? They have asked to explain the rho value. Here you can see, so here they have given the rho values and from that we have to describe the mechanism of this reaction. So there are two possibilities. One is SN1, another is SN2. Now if we see, in case of SN1 reaction, there will be a generation of carbocation. There will be a generation of carbocation. Whereas in case of SN2, there will be a generation of generation of this kind of transition state. Where the transition state is negatively charged. Therefore, when we are adding, in this case, if we are adding electron withdrawing group, what should, if we are adding electron withdrawing group, what will happen? There will be a flow of electron in this side. Okay, so therefore this intermediate get destabilized. So therefore with electron withdrawing group, rho value is negative. So here the rho value will be negative because in case of electron withdrawing group, the intermediate gets destabilized. But in case of electron donating group, the intermediate get stabilized. Therefore, in this case, the rho value will be negative. Whereas in this case, there is a negatively charged. So, if we are adding an electron donating group, it will pull electron to itself. So, the transition state will get stabilized. So, in this case, the rho value will be positive. As we have discussed in the earlier class also, that if the intermediate contains any negatively charged, if the intermediate contains a negative charge, then the rho value will be positive. Then the rho value will be positive, as by addition of electron withdrawing group that get stabilized. But the intermediate or the transition state if positively charged, then by addition of electron withdrawing group that get destabilized. So the rho value will be negative. So from this one, here you can see in both the cases, rho values are negative. So from that you can get an idea that the reaction is going through a SN1 pathway. Reaction is going through a SN1 pathway. Okay. Here and now, if you want to describe it more, you can see when R equal to methyl, it is more negatively charged, and when H, it is less negatively charged. Why? Because the methyl has a plus I effect, and as we know, in case of positively charged intermediate, as rho value is negative, and as much as the electron donating group is there, that get more stabilized, so it will be more negatively charged. I have introduced about this rho star value or other scale in the last class. Maybe you can go and check, it is already in the YouTube. So I think link has been provided by the NPTEL. You can go and check it. If someone has any confusion about this, then it will be clear. Whenever the intermediate is positively charged, the rho value will be negative, and as much as electron donating group will be there, rho value will be more negative. Higher value in the negative zone. Higher value in the negative zone. And if the intermediate or transition state is negatively charged, then the rho value will be positive, and as much as the electron withdrawing group is there, rho value will increase in a positive value. Okay, I hope it's clear. If not, you can go and check the last class. Now there is a question, determine the mechanism using rho value. So there are two reactions they have given from the same substrate, and the product is kind of similar. There is a 1:2 addition product. So they have asked what is the mechanism in both of the cases. So if you see the first one, you see both of them are negative. Both the rho values are negative. So from that what we can get an idea that there is an involvement of positively charged transition state or intermediate. Okay. So as both of them has rho value positive, so from that you can get an idea that both of them has involved a negatively charged intermediate or transition state. Now there is a variation in the value of negative. So to explain that, if we go into the mechanism, what is happening in the first case? In the first case, first this alkynylic carbon will attack to the sulfur and chlorine minus will remove, and then the sulfur lone pair will attack again at this position, and this type of sulfonium kind of cyclopropane will form, and after that the removed Cl minus will attack again at this position because this is benzylic position, and we will get this one as our product. Now in this case there is a partial positive character at this center. There is a partial positive character, therefore the nucleophile is attacking to this position, right? There is a partial positive nature on this carbon. Due to this, the rho value is negative, but as there is no formation of a carbocation intermediate, like fully positively charged, therefore the rho value is quite moderate or less than that of other, is quite moderate. If you look into the second reaction, what is happening here? In this case, similarly the alkyne will attack here and there will be a formation of a carbocation and then Br minus will attack. In this case, from the value of the rho value, we can say that there is no formation of this type of bromonium cation, because if bromonium cation would form, we wouldn't get this much of highly negatively charged rho value, because then this center will be partially positively charged, less affected by a substituent. Okay, so this will not form in this case. The reaction will go through a carbocation intermediate. So here you can get an idea that sign will give you a hint that if the rho value is positive, then intermediate is negatively charged or transition state is negatively charged. Now, if the rho value is positive, then the intermediate is rho value is negative, then the intermediate is positively charged. Now, from the magnitude also, if it is high range of negative value, then what it tells? It tells us that the intermediate which is getting involved is highly positively charged, or a carbocation is getting involved in the reaction. But if it is not that much high value, then we can say that there is a partial positive charge in the intermediate. So, what is the summary of the Hammet rho value? If it is -5 or -6 range, large negatively charged, what I was telling till now, large negative charged rho values means positive charge on the ring, delocalized around the benzene ring. So there is a positive charge intermediate is formed. If it is low, then moderate negative value means the electron flows out of the transition state and positive charge near the ring and loss of conjugation. If small rho values, this means, as I discussed earlier, that if there is a 2 carbon atom, if you can go in the last video, you will get an idea. If the rho value is near 0, not a very in between 0 to 1, then that is not that much affected by the substituent, that is the reacting center is far from the substituent, then the value will be quite less. Now if it is highly positive, then there is a negatively charged intermediate, and if it is too high positive, negatively charged intermediate, and it's getting delocalized around the ring. So this will be the graph. If the rho value is positive, then there will be a positive slope, and if the rho value is negative, there will be a negative slope, and if there is no effect, there will be a straight line. Okay, so let's solve some question which can be based on this. How can we determine if we are how rho value will determine? That is clear, right? You just have to determine the rate constant of the reaction with substituent and without substituent. From that, if we take a log of that, you can get and plot it with respect to the reaction constant. With respect to the reaction constant, you will get a rho value of this. You will get the straight line, and from the slope of this reaction, you will get a rho value. Now, suppose you have given a unknown reaction, and you determine the rate constant of this reaction at with different substituent, and after plotting the log K value with respect to sigma, that is constituent constant, constituent parameter. What we will get? We got a positive slope. This part is for the electron withdrawing. This part is for electron donating. So as much we are giving electron withdrawing group, we are getting a positive rho value. This is this one, positive rho value. Now we know positive rho value means the involvement or the generation of a electron rich product or intermediate. Electron rich product or intermediate. So here you can see what is the reaction mechanism. So there is a, after the formation of this product, this is positively charged, but after the formation of this product, there is an electron on the nitrogen and it can flow inside the ring. So there is a flow of electron towards the ring. So whenever there is a flow of electron towards the ring, that is whenever the product or the intermediate which is generating is electron rich and giving electron towards the ring, then that means rho value will be positive. So from that we can get an idea of this mechanism, that here one proton is getting deprotonated and we are getting this amine, and amine electron can flow inside the ring, therefore it gives a positive rho value. Because whenever it's R equal to electron withdrawing group, there will be a stability of the product will get stabilized and that enhance the reaction rate in presence of electron withdrawing group. From this, so this mechanism correlates with this rho value. Let's go to the next one. What is they what have done? This one is similar to the one I gave for more purpose. So what is happening? This O minus is attacking to this carbon center and I minus gets removed. So the electron is flowing out of the ring, So if we are adding electron withdrawing group, what will happen? It will inhibit the flow of electron. It will inhibit the slower the flow of electron. So whenever there is a electron, so what is the summary? If electron flows out, phenyl ring, that means rho value will be negative. If electron flow into the ring, then rho value will be positive. this. Now next one. What is happening here? In this case, this Cl is getting substituted by this ethoxide. Cl is getting substituted by this ethoxide. So this is a 2-degree carbon. This is a 2-degree carbon. So this is 50-50% probability of SN1 and SN2. There is a 50-50 chances of SN1 and SN2. Now what will happen in this case? SN1 or SN2? What is happening? I'll just give 1 second. Just think. How can you determine? Here we are given the rho value. So how can you determine this reaction is going through SN1 or SN2? So what will happen? As we can see, if it is SN2, I have discussed earlier also, if it is SN2, then the intermediate is negatively charged. Intermediate is negatively charged. Because of that, the intermediate with presence of electron withdrawing group, there is a flow of electron inside the ring. In presence of electron withdrawing group, there is a flow of electron inside the ring. Okay, so whenever there is a flow of electron inside the ring, then it will be positive rho value, and if it is giving flow of electron outside the ring, then it will be a negative rho value. So in case of SN1, a positively charged intermediate is formed, which gives flow of electron outside the ring. So as we know, whenever there is a flow of electron inside the ring, rho value will be, what will be the rho value? Rho value will be positive. But whenever the flow of electron is outside the ring, rho value will be negative. So as the rho value is negative, so reaction is going through the SN1 pathway. The reaction is going through the SN1 pathway. Reaction is going through SN1 pathway. Okay, understood? Let's go to the next one. So this one you guys try by yourself. I will solve this in the next class. So this is similarly, I have given the rho value here. I have provided the rho value. From that we have to determine what will be the mechanism of this reaction. What will be the mechanism of this reaction? SN1 or SN2. So there are some new scales in Hammet plot which are required in the reaction involved direct resonance stabilization, like phenoxide. When there is an electron withdrawing group, there is a movement of electron inside the ring. because of this electron withdrawing group. Now in case of carboxylate anion, the movement of electron from the carboxylate anion to the ring is through one carbon, in the middle. But here the oxide anion is directly attached to the phenyl ring. So the movement of electron towards the ring is higher in case of phenoxide. So whenever there is a electron withdrawing or electron donating substituent, it will get highly affected than that of the benzoate anion. Okay, it will get affected in a higher range than that of the benzoate anion, because this is directly connected to the phenyl ring. Because of this, some other scales have been introduced by Hammet. What is that? That is sigma plus and sigma minus. What is sigma plus? Whenever there is a in case of whenever there is a positively charged intermediate is involved, the sigma value is determined as the sigma plus, and whenever there is a phenoxide anion is getting involved, the sigma value is denoted by a sigma minus. Sigma value is denoted by a sigma minus. You can see the sigma minus correlate with the value of sigma, which is for the benzoate anion. So these are correlating. Just the value is higher than that of that. Whenever this is 0.05, this is 0.08. This is correlating. But in case of correlating. So there are some other scales which was introduced by some renowned scientists like Yokawa, Tosunu, Florz, and other is Taft, Thompson, Plot, but these are not that much required to determine a reaction. You can this equation has been involved to overcome the other limitation of the reaction. So this is a for now we are not discussing that. So the next topic is deviation for linear free energy relation. So as you have known from Hammet principle, we have known that the log k by k0 equals to sigma rho. Now in some cases, and by plotting log k by k0 versus sigma, we get a straight line, and from that we get a rho value from the slope of the straight line. Now there are some reaction where we can't get, if we go into the experimental values, we can see that there is a deviation in the linearity of the line. That is, the line is not straight throughout the process. Like if we know that if in case of the rho value is positive, the line is have a positive slope, and if the rho value is negative, the line will have a negative slope. But there are some cases where in the same reaction we can get both type of rho value, that is positive and negative. Here you can see in this case, this acyl chloride hydrolysis reaction. If we look into the reaction, when electron withdrawing group is added, we get a positive rho value, and in case of electron donating group, we get a high negative rho value. So how is this possible? As we know, when the rho value is positive, there is a movement of electron inside the ring, that is, there is a involvement of negatively charged intermediate. But when a rho value is positive, a rho value is negative, that means the flow of electron outside the ring, that is, a positively charged intermediate is getting involved. This is possible only when there is a change in the mechanism while changing the substituent. This is only possible in that case, because from the graph you can get an idea that the intermediate nature is getting changed. Here Here the intermediate is positively charged. The intermediate is positively charged, whereas in this case the intermediate is negatively charged. This is only possible when there is a change in the mechanism. So if we look into the mechanism, what is our mechanism 1? What is the mechanism 1? One probability is there when that the OH2 is directly attacking to this center and Cl- is getting removed. In this case, a negatively charged intermediate is getting involved, whereas in this case, after removing the leaving group, a oxonium carbocation is formed where the OH2 will attack and form this type of product. So from this one, there is a positively charged intermediate is getting involved. So in this we can see, from this we can see, when from this what we can conclude, when there is a electron donating group, when there is a electron donating group, whenever there is a electron donating group, it prefers the negative charge. That means it prefers the formation of the carbocation intermediate. So whenever there is electron donating group, what will happen? Whenever there is electron donating group, it prefers the negative charge, means there is a formation of the carbocation. That means reaction goes through this pathway. Whenever there is electron withdrawing group, reaction goes through this pathway. But whenever there is electron withdrawing group, it prefers a positively charged intermediate, positively charged rho value. That means there is a formation of a negatively charged intermediate. Positive rho value means negatively charged intermediate, and negative rho value means positively charged, just reverse. So whenever there is a positively charged rho, so that means there is an involvement of a negatively charged intermediate, which means whenever there is an electron withdrawing group, the reaction goes through this pathway. Okay, it's clear? So in the same reaction, just by changing the substituent, the mechanism can change, and that therefore there is a deviation in linear free energy relation has been observed. So just by changing the substituent, we can change the mechanism of a reaction. So from this we can get an idea, like suppose in laboratory some reaction is happening in a predominant, but we want the reaction goes through another pathway other than that one. So just by changing a substituent, we can affect the reaction mechanism of the, we can affect the reaction mechanism. This is another example where there is a deviation was observed. This is a cyclization type of reaction through a carbocation pathway. Here first this OH2 will remove and a carbocation will generate, and after that the cyclization will take place. You can see whenever it is the reverse of the previous one, whenever there is electron donating group, whenever there is electron donating group, we get a rho value of positive. We get a positive rho value. Whereas the electron withdrawing group is there, we get a negative rho value. From this overview, what we can say that formation of the cation, normally the rate determining step in this reaction with the negative rho value goes faster as electron donating group is there. So there is a formation of a carbocation, and as rho value is positive, that means reaction is going through a carbocation intermediate, and that is the rate determining step. But suppose when this type of carbocation formation is complete, now this step becomes the rate determining step of the reaction. After suppose all this substrate has been transferred to this carbocation state. Now after that this reaction gets slower, and now this reaction becomes the rate determining step. Now in this case, you can see this carbocation intermediate is formed. So as much whenever there is a carbocation intermediate, there will be a formation of negatively charged rho value, that is there is a movement of electron outside the ring. But after that, when the second step now the carbocation has gone inside the ring already. Now by elimination of the hydrogen atom, we get the electron movement inside the ring. So see, here the electron is moving outside the ring, while to regenerate the aromaticity, that CH bond is getting removed and the electron is moving inside the ring. So whenever the movement of electron is inside the ring, then that will be rho value will be positive. So here what is the idea we are getting from this reaction? From this reaction we can get an idea that in a single reaction two rate determining steps can be present. After one reaction is getting completed, another reaction becomes a rate determining step, and in that case the effect of substituent can get reversed. See, here the values are almost same because the effect is controlled by the same ring only. So the effect is totally reversed. The values are comparable. Just with different charge, because here the movement of electron is inside the ring and is outside the ring. So whenever you are drawing a mechanism, try to draw it by your hand or any pen or something, so that you can get an idea and move the arrows, that how electrons are getting moved, how when SN2 is happening, how electrons are attacking, that how the movement of electron is taking place. From that you can get an idea that there is a movement of electron outside the ring or there is a movement of electron inside the ring, and from that you can get an idea of the mechanism or the rho value. Okay. Let's go to our next topic, which is solvent effect. Now in chemistry, solvent effects are the influence of a solvent on a chemical reactivity or molecular association. Now solvents can have an effect on solubility, stability, reaction rates, and thermodynamic and kinetic control over a reaction. Now different solvents can affect the equilibrium constant of a reaction by differential stabilization of the reactant or the product through hydrogen bonding, dipole-dipole interaction, van der Waals interaction, etc. So there are two types of solvent. First is protic solvent, second aprotic solvent. What is protic solvent? Protic solvent means which easily gives hydrogen. And these are also the variation of polar solvent. And when it is aprotic solvent, that doesn't give any hydrogen atom, and it can be two types, that is polar and non-polar. Whenever that is protic solvent, that is obviously polar, as it giving hydrogen atom, so there will be a generation of negatively charged, so that is all obviously polar. But whenever there is aprotic solvent, there is a two probability. One is protic, one is polar, and another is non-polar. How it can get polarity for aprotic solvent? If it is not giving hydrogen, but still there is a dipole moment in the solvent, then there will be a polarity in the solvent. So this type of solvent like TMF, TMS, so this doesn't give any proton, but it acts as a polar solvent. Whereas this type of non-polar solvent like alkanes, alkyl halide, ether, this acts as a like DCM, chloroform. This type of system acts as a non-polar solvent. Now, if we look into this reaction, we can get an idea of solvent effect on a reaction equilibrium. Now, if we take this 2-hydroxypyridine, this form of this pyridine is called enol form. So there is a double bond and hydroxy, so this is the enol form, and this is ketone. Now all know about ketoenol tautomerism. How this takes place? There is a bond. If it comes here, there will be a ketoenol tautomerism is possible. Now, as much as solvent polarity increases, we can see that the keto form get stabilized. Therefore, just by controlling the solvent polarity, we can get this product in a higher amount in this reaction. If we decrease the polarity of the solvent, what we will get? We will get this one as our sole product. But when we increase by increasing the solvent polarity, we can change the outcome of a reaction. Now, how solvents affect the kinetics of a reaction? So, whenever there is a solvent stabilize a reaction, it stabilize all the states like transition state and substrate both. Now, in some cases, if suppose you are adding a polar solvent. So if your intermediate is polar, that will get more stabilized, and because of that the rate will increase. Here what is happening here, here first there is a deprotonation happens and the intermediate becomes negatively charged. That means the intermediate becomes polar. Because of that, by adding polar solvent, the intermediate gets stabilized and formation of the intermediate becomes faster, and it can easily tautomerize into this keto form. So similarly, whenever there is a generation of negatively charged in the intermediate, that gets stabilized, and as well as the substrate also gets stabilized. Now, if your intermediate has more negative charge than that of your substrate, that will get stabilized in a higher extent than that of your substrate. What I am saying, suppose so what is happening here? You can see our substrate was uncharged, but our transition state is charged now. partially negatively charged. Because of that, partially negatively charged. Because of that, whenever there is a polar solvent is added, what will happen? That will stabilize the transition state in a greater extent than that of the substrate, because our transition state is negatively charged. We all know that a negative charge, a charged species is getting stabilized by a charged species in a greater extent. Suppose if you are placing a magnet in a magnetic zone, that will attracted by that magnet in a greater extent, so it will get attracted, it will move, or it will get the energy of that one will get stabilized. But if you are placing a non-magnetic thing, then it has no dipole moment, that will not get attracted by those magnet, or there is no reduction of this energy of that magnet or that substrate. So therefore, whenever there is a charged species or charged transition state, that will get higher stability in a polar solvent in comparison with the substrate. But in case of this type of reaction, when the substrate is charged already, like this, positively charged, and you are adding a nucleophile. So in this case, the transition state has a partial charge in it. The transition state has a partial charge inside it, but substrate has a solid positive charge inside it. So therefore, this is more polar than that of inner transition state. So this is more polar than that of transition state. So in a polar solvent, that get higher stability than that of the transition state. So if we see the reaction, the energy profile diagram, you can see whenever the transition state is getting more stabilized, there is a activation energy gets lower. But whenever the substrate get more stabilized, the activation energy is not that much lower in this case, because the substrate, as along with the transition, the substrate is getting also stabilized. So the reactivity nature of the substrate is getting reduced. The reactivity nature of the substrate is getting reduced. Suppose this type of, you are adding some polar solvent, how it will be trapped by the solvent. The solvents will surround it. Like if there is a polar solvent like water, what will happen? The water molecule will cover this substrate like this way. Water molecule will cover the substrate like this way. So what will happen? This will inhibit the nucleophile to come and substitute the leaving group. Because of this, the activation energy of the reaction increases. Because of this, the activation energy of the reaction increases, because it is unable to react with the substrate easily. So from that, what is the conclusion of this topic? That whenever our transition state is more polar than that of our substrate, that will get more stabilized by a polar solvent, and because of that, there is a reduction in activation energy. But if your substrate is more polar than that of your transition state, then by addition of a polar solvent, the substrate will get more stabilized than that of the transition state, and because of that, there will be a less reduction in activation energy in the reaction. Okay. So what is happening, if we apply this solvent effect in SN1 and SN2 reaction, what will happen? So in case of SN1 reaction, what is the intermediate? The intermediate is the carbocation intermediate, that is a highly positively charged intermediate. So our substrate is neutral, but in the intermediate we are getting a positively charged intermediate. Because of that, see that the transition state is carbocation, the transition state is here, the transition state is the carbocation, so it is highly positively charged. It is highly positively charged, that is polar, so it will get more stabilized than that of our substrate. So our substrate will be around at the same position because these are non-polar. The substrate was not uncharged. The substrate was uncharged. The reactant was uncharged, but the transition state is charged. So because of that, it will get more stabilized. But in this case, the substrate, in case of session 2, when a polar solvent is added, the substrate has a good leaving group, that is all this type of SN2 is having this type of substrate when there is a good leaving group. So the substrate is already positively charged. Because of that, will get more stability in the reaction. So the reactant will get more stabilized in the polar solvent than that of the transition state. Because of that, the reaction rate will get reduced. Okay. So it's clear. Up to this is clear. So what is our solvent effect? The solvent affect our reaction by stabilizing our substrate and transition state. If transition state is more polar than our substrate, it will get more stabilized by a polar solvent and therefore the reaction rate will increase. But if reverse is happened, that our substrate is more stabilized than that of the transition state, then there will be an increase in activation energy. Then there will be an enhancement in activation energy. Now our last topic of today, which is the kinetic isotope effect. So what is kinetic isotope effect? So it is a change in reaction rate of a chemical reaction when one of the atom of the reactant is replaced by one of its substrate formally. So this is that if you have taken, suppose you have taken CH3Br, methyl bromide, or tertiary butyl bromide, okay, like this type of substrate. Suppose you have taken this type of substrate. Now just change this proton with deuterium. Now this type of substrate undergoes a E2 elimination type of reaction. Now what scientists perform? They just perform reaction with these two substrates. One is with deuterium and another is with hydrogen, and measure the rate of the reaction. And they taken when there is a ratio of the light, that is the kH by kD, involving the kD by kH. If we have, this is the KL or KD by kH, then whatever value they got, that is called kinetic isotope effect. This gives us an idea that this isotopic bond is getting cleaved by at the rate determining step or not. Means if the rate is getting affected by this CH bond, just by replacing the CH bond with deuterium, if the rate varies, then from that we can get an idea that the CH bond is getting broken, or that this specifically this whatever bond they involve, that bond is gets broken in the rate determining state. Because if it is not involved in the rate determining state, by changing this hydrogen with deuterium will not affect the reaction rate that much, or any extent. But as just by changing one atom with this isotope, if we can vary the reaction rate and this kinetic isotope is not equal to 1, then that means it's showing some kinetic isotope effect. But if it is equal to 1, then there is no such kinetic isotope effect and the hydrogen bond is not getting broke at the rate determining step. So there are two types of kinetic isotope effect. One is primary kinetic isotope effect, another is secondary kinetic isotope effect. So we will discuss about primary kinetic isotope effect in this class. Next class we will discuss about the secondary kinetic isotope effect. So what is primary kinetic isotope effect? If this kinetic isotope effect value is greater than 1, then that is called primary kinetic isotope effect. What does it mean? You can see the kinetic isotope effect is equal to Kh by Kd. This is equal to Kh by Kd. Now, if this is greater than 1, that means the Kh is greater than Kd. That is, rate of a reaction with a hydrogen atom is higher than the rate of the reaction with a deuterium atom. So that means in presence of deuterium, the rate of the reaction gets lower, because as we know, the deuterium bond is stronger than that of the carbon hydrogen bond, which needs higher amount of energy to break and needs more time to react. So if the reaction involves the hydrogen and that hydrogen is getting replaced by the deuterium, you can get an idea that that bond is getting broken in the transition state, in the rate determining state or not. Suppose this reaction is given. Now what will happen? This one will come here and it will get removed. So this is a E2 elimination. Whereas this one will come. Now here, if we replace this hydrogen atom with deuterium, what we can see, there is a decrease in rate. So that means Kd is less than Kh. There is a decrease in rate, and therefore it proves that our hydrogen atom is getting broken at this rate determining step. So suppose now for this reaction you have to determine the kinetic isotope effect. What will be the kinetic isotope? That Kh by Kd will be equal to 1 or greater than 1. Secondary you haven't studied yet, so I will not give a question from that. So here just you have to determine that this kinetic isotope effect will be greater than 1 or this kinetic isotope effect will be greater than 1 or equal to 1. That we have to determine. So if I have told several times that if our reaction involves the breaking of the hydrogen atom at the rate determining step, that means by changing the hydrogen atom with the deuterium we will get a kinetic isotope effect, but if it is not, then it will not get a kinetic isotope effect. So what to determine the kinetic isotope, what we will have to discuss first, that what is the mechanism of this reaction. If we know the mechanism of this reaction and what is the rate determining step of the reaction, we can easily determine that it will show kinetic isotope effect or not. Because if we know the mechanism, then you can get an idea that which is the rate determining step, and if in our mechanism, if the rate determining step contains the breaking of the hydrogen atom, that means it's showing kinetic isotope effect. So if we go to the, this is the normal electrophilic addition reaction. This we have discussed in the last on the, no, in the, this we have discussed in the class week 3. I think in the third week we have discussed this electrophilic addition type of reaction maybe. So just go to that slide and check what is electrophilic addition, because if you don't know the electrophilic addition and how this happens, if you don't have any idea of mechanism, you will not understand that how we are getting this idea that if this will go this way or this will break this way. You have to know that what is the mechanism of the electrophilic addition reaction. If you haven't seen that video, go and check week 3 video. It's already in the YouTube. My YouTube channel is Chanda Demnath PMRF. If you search by name, you will get it. Or by the course name also. If you search by mechanism in organic synthesis, organic chemistry, from that course name also you will get that idea. So what will happen? What will happen? So in this case, this one is the RDS. So in this case, the hydrogen atom is getting broken in the first step. So by changing the hydrogen atom, it will not affect the reaction. So what will be the value? So the kinetic isotope effect will be equal to 1, because our hydrogen atom is not getting broken at the rate determining step. Okay, I think it was easy. So you just have to know the mechanism of the reaction, then you can determine the KH by the kinetic isotope effect. If you know mechanism, if the reaction hydrogen atom is getting broken at the rate determining step, then like clearly you can just mark that it will be greater than 1. Now they have given the value, this is already greater than 1. From that you can get an idea that hydrogen atom will get broken at the rate determining step. Now you have to solve this one. So how will it form? You have to break the hydrogen atom at the rate determining step. And you have to invert this hydrogen. See, they have changed this hydrogen atom. So this hydrogen should be broken at the rate determining step. So what will happen? I just give 1 minute. Let's check. Let's try. what will happen then? Okay, so here you have to determine, suppose now we just replaced this hydrogen atom with a deuterium. And we are getting this intermediate. So here, if we this goes here and this take of this deuterium. Now from this we can get an idea that if the hydrogen is getting replaced by the deuterium, how we can know that there will be this proton will be replaced? Because you can see that they have shown that it is OH or OD. That means this oxygen is getting proton once, and another in one case oxygen is getting deuterium in one case. So from that you can get an idea that how can oxygen get a deuterium? Because oxygen is taking proton from this position, so this proton should be replaced by the deuterium. Now from the Kh by Kb value you can get that if we replace this hydrogen with deuterium, the rate will get slower. So that means this is our rate determining step, because our rate is getting slower while changing from Kh hydrogen to deuterium at this position. Okay, so this is our overview of this today's class. What we have discussed today. So we are continuing the Hammet principle. So here is the homework I given in the last week. So I have solved this for you. Then we explain this question that so summary of this Hammet equation is that if there is a flow of electron outside the ring, then it will be negative. The rho value will be negative, and if there is a flow of electron inside the ring, the rho value will be positive. If there is the involvement of carbocation or positively charged intermediate, then the rho value will be negative. If there is the involvement of negatively charged intermediate, rho value will be positive. Just reverse. If the intermediate is positively charged, rho value will be negative. Like carbocation, it is negative. But the rho value is, if the intermediate is negatively charged, like benzoate anion, like benzoic acid and benzoate anion, then the rho value will be positive. Then we solve some question where you determine the mechanism based on the rho value's nature. I have given one question to try yourself. If I will upload the slides where you can get the question, just try by yourself so that you can get an idea how rho value is involving in a reaction, or how rho value is helping us to determine the mechanism of the reaction. Unless you solving question, you will not be able to solve unknown problems. In my case also, if I am not solving examples, after 2 weeks or 3 weeks or 1 month, I won't be able to memorize all these questions properly, because it's a bit confusing. I am again and again saying, but it's if you don't go through it or solve problems regarding this, you will be, after some time you will get confused that how the rho value is varying in a reaction. So just practice so that you get a refresh idea that what is happening. As much as you solve the question, the idea will be clear, so that you can solve any question, any problem, any reaction of this world. So just try to practice as much as possible. Then we discuss about some different plots, then some deviation of this Hammet principle, where we are getting two different type of rho value in a single reaction. From that we can conclude that just by changing the substituent, the mechanism of the reaction can also change. There is another example which we have shown that from that we can get an idea that after formation of one intermediate, there will be a change in rate determining step of a reaction. So in this case, after complete formation of this intermediate, the rate determining step becomes the second one. Initially the first one was the rate determining step. So the substituent control of this reaction, because the electron is moving outside the ring, so therefore the rho value will be negative in this case. But after the formation of this intermediate, this step becomes the rate determining step of the reaction. Because suppose a relay race, someone has run the race, now he has stopped, so after that someone else is running, so the rate of the race is dependent on the other one which is running now. Okay, so in this case, the formation of the carbocation was controlling the reaction rate, but after the formation of the carbocation, the reaction is not controlled by this one anymore. In this case, the then reaction is controlled by the second step. The rate determining step got just changed by completion of the intermediate. Then we discuss about the solvent effect and how is controlling a kinetic of a reaction. Then what is the effect in case of SN1 and SN2 reaction. Then we discuss about kinetic isotope effect and what is primary kinetic isotope effect, and two examples based on that. We will continue this kinetic isotope effect in the next class, and we will discuss about the secondary kinetic isotope effect as well. Okay, thank you everyone. Have a nice day.